Good morning or afternoon, and welcome to the Diyotta webinar. Thank you for joining this morning or afternoon, depending on where you happen to be. This morning's webinar is Making Data Integration Easy for Multi-Platform Data Architectures with Diyotta 4.0. A few logistics for everyone who has joined. First of all, if you have any problems with the sound on your computer, I would encourage you to switch over to the phone and dial in. Second, questions will be answered at the end of the presentation. So throughout the entire presentation, feel free to submit your questions through the Zoom control panel on your screen. And then third, we often get asked this question, and so for your convenience, the slides from the presentation and a link to the recorded webinar will be sent to you within 48 hours of the webinar. Your speakers this morning are, first of all, Philip Russom. Philip Russom is the Senior Director of TDWI Research for Data Management. He has published numerous resource reports, magazine articles, opinion columns, and more. Before joining TWI in 2005, Philip Russom was an industry analyst covering business intelligence at Forrester Research and Giga Information Group. He also ran his own business as an independent industry analyst and BI consultant and was a contributing editor with leading IT magazines. Your second speaker today is going to be Ravi Panuru. Ravindra Panuru is the Chief Technology Officer at Diyotta and founder. He co-founded the company with two others. Between them, they have a total of more than 50 years of data integration expertise. He is responsible for the roadmap and the product. His own 20 years of experience in data integration include times working with major banks like Bank of America and communication companies like Time, Warner Cable, CenturyLink, and AT&T. With that, I'm going to go ahead and turn it over to Ravindra.
Thanks, John. Hello, everyone. Good morning and good afternoon. Thank you for joining the webinar. Today, we are really excited to announce our new release 4.0. With this new release, we are introducing the features to support cloud data warehouse technologies like Snowflake, Amazon Redshift, and Google BigQuery. And also, we are bringing a new feature to support real-time data streaming, which allow our customers to implement Lambda architecture use cases. I'll be going over in detail on these new features in my presentation. For now, I will hand over to Philip for his talk on multi-platform data architecture.
Well, thank you, Ravi, for getting us going here. And John and Ravi, can you hear me okay today?
We can hear you great.
Thank you, John. And also, my special thanks to everybody attending or listening to this webinar from an archive. I know you've got plenty to do, so we really appreciate the fact that you can find the time to join us today. So today I'll be talking about what at TDWI we call the multi-platform data architecture. And John, I'm having a little trouble getting the slides to advance. Here we go, now it's going. So listen, for my agenda, I'm going to give some background and define what these multi-platform data architectures are. I think once you hear my definition, you'll go, oh yeah, I work with those. So these are fairly common things. I'll also give you a reference architecture so you know what the common components are within a multi-platform data architecture. And I've got all kinds of examples. I'm going to give you a detailed one about multi-platform data warehousing, but we'll also hit other examples from the world of marketing, supply chain, industries like financials and insurance and so forth. So we give you some real-world examples for those. And I'll talk about what are some of the critical success factors. So if you have a large, complex, probably hybrid data architecture, I'll talk about what your priority should be if you expect some success there. And today we'll also put a special spotlight on data integration because when you have sometimes dozens of platforms, and they can be different database brands. You'll see the Hadoop and cloud and all kinds of things are mixed up in there today. Then that's a special case for data integration, and anything that moves data, integrates data, aggregates data, and also in my world, you're processing data for analytics and reporting. So we'll hit some details about that. But you know, the real background here, the reason that these multi-platform data architectures have shown up is that the world of data is just increasing in complexity, isn't it? And I know many of you are still dealing with old data from traditional on-premises systems, and yet you're also dealing with new data from new sources. Maybe say your new source is the Internet of Things, or you're finally addressing web applications, social media, etc. And so when you have this eclectic mix of old and new data, you got just about every data structure imaginable, and every source, every structure has got its own requirements for how you capture it, how you store it, how you process it in place, how you integrate it across platforms, and so forth. You know, also many of you are dealing with different latencies, because if you look at old and new data sources, some of them are pushing data to you in real time, and that's new for a lot of you. And you have to learn how to deal with streaming data, real-time data, near-time data. But you also have other sources where it's really just kind of old-fashioned batch, or it might be a more modern micro-batch approach to it. But you get the idea. I think you understand the kind of environment I'm talking about. It's a data environment where we've got a mix of old and new, traditional and modern, on-premises, on cloud, on some of the new platforms like Spark and Hadoop. And with this increasing complexity, we also have some increasing complexity in the world of data management. And so so if you look at data integration and other data management solutions, you're going to have a mixture of homegrown solutions, maybe vendor-built solutions. And I know many of you are addressing open source for all kinds of solutions, including data integration. And so with these multi-platform data architectures, it's really where you have a long list of architectures, and the data is distributed and heterogeneous when you look at it across all those platforms. And the old stuff are like relational still there, but Hadoop and other modern things. So at TDWI, we had to give a name to this thing. So we're calling it the multi-platform data architecture. In the past, we used to just call them distributed data architectures, and distributed is a good word, because that has long meant that data is physically located in many different places. But we kind of like the term multi-platform because that helps you to visualize. It helps you to automatically jump to the correct conclusion, which is that there are lots of different platforms here, as I've already described. So that's where we got the term multi-platform data architecture. And the definition of this thing is pretty simple. A multi-platform data architecture is just a combination of traditional and newer platforms. And let's talk about this diversity for a minute, because the diversity is not new, but the intensity is. For example, if you're in data warehousing like me, if you just think back to the old days, like the 90s, even from the beginning of data warehousing, we've argued over, well, where do we put certain data? Like we have data mart data, does that go in the same platform as our core data warehouse? Or do we get a standalone platform for that? We did the same thing with operational data stores. Does that go in with onto the core platform, or does it have its own, this kind of thing? So we've been having these kind of conversations for many years in data warehousing. But the thing is, today, the number and the different types of platforms involved is much bigger than ever before. See what I mean? So the diversity isn't new, but the intensity, the long list of many platforms involved is there. And today, one of the things I'll stress is that having an architecture for these environments can definitely help you, and can actually hinder you if you have not allowed an architecture. Sometimes these multi-platform architectures kind of evolve, especially if you work in an industry like financials or insurance, where there's always another merger and acquisition coming. A lot of times you end up with this, this huge bucket of platforms that were never meant to coexist. And when you make them coexist, you need an architecture for them. So what do you need to make that architecture work? Well, in my opinion, you need pretty hefty integration technologies and tools. And this is especially for data integration, because we're talking about a data environment. However, if you look at some of the real-time data requirements for like streaming data, the Internet of Things, and stuff like that today, you may need application integration technologies, things for like services, for buses, for event processing. And then also, just so that you have kind of a centralized way of recording what data is there in the inventory, you need really advanced, fully modern metadata management. So put those together, that's a pretty hefty data management infrastructure. You probably also want some logical and virtual technologies, because a lot of the data you're going to deal with on multiple platforms, you don't really have the option of moving it around that much. So a lot of times, if you can just do federated queries across multiple platforms, instantiate data on the fly, that's actually a better thing than moving terabytes of data around. So let's take a look at a reference architecture that has a data lake in the middle, because I know many of you in data warehousing have embraced Hadoop, and you may be following data lake principles on Hadoop. And by the way, if you're waiting for my slides there, just be patient. The pieces will eventually appear on the slide. So in the middle of this reference architecture, I've got Hadoop on a data lake, and that's for many people, the Hadoop and the data lake are the integration portion of their architecture for warehousing. This is where data is ingested. It's where it's transformed, aggregated, where it's prepared for being loaded into target systems. This is true whether the data is coming from new sources like machine data and web data, or from traditional data sources like the usual three-letter acronyms, CRM, SFA, and ERP. On the outbound side, you may be, even though you've got a modern data lake and Hadoop in the middle, you may be feeding older platforms that you've been using for years, like the data warehouse and similar things like a string of data marts. And but today we're seeing people also keeping the warehouse in place for certain things, especially reporting, but putting specialized database management systems or other systems next to the warehouse. We especially see a lot of columnar databases next to the core warehouse, and the columnar database is there for SQL-based analytics and things like that. Now, one of the nice things about having a lake on Hadoop in the middle is that you can partition Hadoop. You can impose a design on your data lake so that you have areas for data that's inbound. So you have ingestion zones. This is what we used to call landing and staging areas. Now we talk about ingestion. This is where data from ETL or ELT comes in. But this is also where the modern stuff, the streaming data and event processing, comes in. And in the middle, you could also have zones that are there very specifically for other tasks like analytics. Because I know a lot of you, come on, admit it, for years, a lot of you have been using your landing and staging area as a place for storing much of your detailed source data that's going into analytics. And detailed source is great for data mining, statistics, for clustering, and those forms of analytics. So, we might as well just admit, okay, there's a fine line between landing and staging and analytic places where we keep our analytic data. You can also partition areas in the middle here, because some of this income dating will probably go to departments like marketing departments, sales, and financials have a long history of being involved in data warehousing, reporting, and are growing even more into analytics. So they need an area in here. So functional zones like, departments of your company. You may also have an archive zone at the middle. And of course, this is a multi-platform data architecture. So there are many diverse platforms at the lower levels of the architecture. So this could be web, client, server architectures. You'll have a variety of storage mechanisms down there. Some of you may have a data environment that's based on clusters, racks, grids. And of course, clouds have just been coming on steadily for years, and especially in warehousing and analytics. And of course, hybrid combinations. Most people, when they say hybrid, they're thinking of a mix of on-premises and on clouds, but you could also have, all kinds of mixtures in a multi-platform data architecture. And so just briefly note that if you look on the left side of this chart, you'll see that way back in the 1990s, the single monolith data warehouse was the norm. Single monolith just means we have one database instance of one database management system. And that's how I always taught to do warehousing in the 90s, right? It's just real simple. Only about 15% of warehouses today are like that. Most other platforms realize that, we cannot, let's admit it, we cannot optimize one core warehouse for every analytic workload imaginable. That's why we need multiple platforms in the middle. because we had different storage workloads, different processing in place workloads, and different transformation workloads, et cetera, in the middle there. Well, I think by now you've got a good sense of what the multi-platform data architecture, but let's talk about what it's not, because this can give you some things that really you should avoid. For example, you should avoid a big bang enterprise information model. That's where you take 6 months off and create a large information model for the whole company, and this is your idea of how to integrate and pull together your multi-platform data architecture. And you know, nobody's going to let you take 6 months off to do this. And by the time you get the large model ready, the company's evolved and the model doesn't apply, especially if there's a merger and acquisition in there, right? So avoid the big bang thing and try to, later we'll talk about how to put an MDA together by stitching it together one piece at a time. So do that instead of the big bang. And also be careful that you don't just think of the MDA as a portfolio of platforms and tools. It's got to be more than an inventory. It's got to be more than a portfolio. All the tools have to be integrated and interoperating with each other. They need to be sharing data where appropriate. You need a true architecture, which in many ways is about relationships among the components and how information travels across those components. And also, similarly, the MDA is not a mere technology stack. It's not about just stacking up different technologies from your hardware servers through the operating systems, then database management systems and end-user tools. All those have to be integrated together and so forth. And then also, I know a lot of us, we initially think about data at rest when someone says data, but the MDA more and more is really about data in motion as well. It's about both. And this is because one of the things the modern multi-platform data architecture does is to capture data from new sources. Well, for a lot of you, some definition of the Internet of Things is your new source, and a lot of that data is streaming, right? So you need special technologies added into the mix of the MDA so that you have technologies that can capture streaming data, that can process triage data in real time, move it to the appropriate place based on what's happening, and do it very quickly, right? And then also, one last thought, with the average MDA, you should just assume data is going to move across the platforms that are within this architecture. So sometimes that data moves in batch, and sometimes it has to move in real time. Okay, so let me hit some real-time platform, let me hit some real-world examples of multi-platform data architectures. I already talked about the multi-platform warehouse environment, and I gave you a reference architecture. I got to say, that's a very exciting environment, but probably the second most exciting environment in the enterprise today would be omni-channel marketing, which is sometimes called multi-channel marketing. That's where marketers are collecting data from different customer channels. And, with cases like that, every channel could have its own data requirements in terms of capture, storage, processing in place, and then being pushed on to analytic uses as well as operational uses. Don't forget, it's not just about customer analytics, it's also about campaign management and things of that nature. The digital supply chain has just been amazing to watch in the last 15 years or so. I remember when I worked in supply chain, it was a lot of phone calls and fax machines, and then we moved on to electronic document interchange-based systems, which then got replaced by XML systems. But at least the information was digital, and it was being transmitted close to real time and being stored so that we could do searches and lookups on it. And then today we're getting beyond XML. JSON's coming on strong as a way of structuring a lot of supply chain data. So if you're dealing with EDI, XML, JSON data, a lot of supply chains generate a lot of transactions. So if you're dealing with events and transactions in the supply chain context, that again can be a very large, complex, multi-platform data environment. And we do see environments like that in a variety of banking companies and other financial services. Don't forget, a large modern financial services company is actually multiple businesses. It can be more than banking, right? It can also be investments, it can be mortgages, it can be other types of loans, and so forth. So, each business there can share the same customers across them. So you want to be able to work data for individual businesses, but also make correlations across them. That helps you to understand your customers better. Also helps you to grow individual accounts and do the cross-sell and upsell. We have a similar situation in insurance because it's almost as customer focus as banking and financials are. But in insurance, you have this special thing called the claims process. And if you think about all the information that has to be gathered anytime there's a loss or a claim, then that's a lot of information that can come from many sources and can be expressed in many data types. And then, of course, the biggest problem of insurance continues to be fraud. So you want to collect data in certain ways, prepare it, and even acquire third-party data about individual people so that you can make analytic correlations to detect fraud. And of course, actuarials and all the risk calculations that go with that quite often involves multiple platforms for the different types of data. So some critical success factors I want to point to would be that one way to create the architecture for a multi-platform data environment is to create it one thread at a time. And there's even a term for that. The so-called data fabric is typically weaved together one thread at a time. It's more like a patchwork quilt than a seamless fabric, but you get the idea. So you know, a lot of times these MDAs, they're not 100% integrated. They're integrated to the level that makes sense, to the level that meets business requirements and technology requirements. So don't go expecting every imaginable kind of interoperability, interface, API, that sort of thing in play here. You pick and choose the ones that you really need based on business and technology requirements. And so basically anything that's a cross-platform process can be a kind of thread to stitch together the data fabric. And these quite often involve integration technologies like data hubs, shared data structures that can be seen through shared metadata, virtual and logical views, federated queries, and so forth. And then I've already mentioned some of the other successful factors, which is, you know, there is a certain amount of inventory of systems and a kind of portfolio management technique you can bring to the multi-platform data architecture. But, you know, it has to be more than just a bucket of stuff. It has to be about their relationships, how they interoperate, and how that is serving the business. So to finish off here, let me tell you to look for solutions for multi-platform data architectures that give you a variety of things that can minimize the kind of work and infrastructure that has to be deployed for data integration and also related data management tasks like data quality, master data management, data replication, the metadata management that goes with that, and so forth. So you need a hefty data integration infrastructure, but you need something that's unified, something where it's pretty much one tool environment as opposed to, you know, a handful of them. Last thing you want to do is ping pong from data integration tool to another, while you're also ping ponging from one data platform in the MDA to the other. So what you want to do is maximize your uses of the MDAs, and so you want to look for really good, solid data processing, maybe in the form of ELT, because you know, you've got to get the data into the MDA, into the platforms of the MDA. And like I said earlier, it's not just about data in storage at rest. It's also about data in motion to the extreme of streaming data. You want to maximize reusability by sharing artifacts and data standards. You'll need special tools for that. A lot of times these things are shared through a metadata repository. And also that metadata repository should be centralized and shared so that people have a fairly common way of describing the data that's available from a variety of tools into the MDA. And then finally, we are assuming here that we're talking about big data. It could be big data from the original definition coming out of web applications, and it could be big data in the more recent variation of that, which is the Internet of Things, which is just relentless about generating data, isn't it? So you need to be able to scale all the systems, especially the data integration infrastructure, and you need to scale it in all directions. You need to scale it horizontally into great bandwidth and multi-threading. You also want to scale it vertically into greater data volumes, because the data volumes are just going to get bigger. Also, I hadn't talked about it today, but you probably realize that these distributed systems in the multi-platform data architecture are strewn across multiple geographies. So you want something that can work, you know, worldwide on a global scale with multiple system types. Okay, well, thanks for your patience, for allowing me to breeze very quickly through our definitions of the multi-platform data architectures and what you want to do with these in real-world use cases, as well as the importance of making data integration easy across the multiple platforms.
Ravi, over to you. Ravi, you may be on mute. We're not hearing you right now.
Hey, John, can you hear me now?
Yes.
Okay, hey, sorry about that. Thank you, Philip, for giving us a clear understanding on multi-platform data architectures. In my presentation, which I will go over, my agenda here is, three things. I'm going to address, how data integration on multi-platform architectures. Then I will deep dive into Diyotta 4.0 features, and followed by the live demo. So with that, I think everybody by this time, I think we have clearly understood that multi-platform data architectures are known for most of the companies today. This slide shows here the typical data fabric, including traditional. Let me highlight this. Traditional data warehouse repositories, which includes EDW, ODS, and data marts like that. And we have emerging technologies like Hadoop and the cloud data warehouse. And the data is coming pretty much many sources like operational source systems and emerging source systems like social media or cloud sources, or you have regional source systems or compartmental source systems. So pretty much data will flow through any of these sources to one or more these data repositories, or sometimes, you have to build certain facts and move the data to your cloud warehouse, and or do some sort of batch processing in a Hadoop and bring back to your EDW for further downstream systems. So basically, the data is going in every direction. Most of the time, organizations doesn't realize that they're building silos of data integration processes, which will eventually become complex and challenges to maintain. And on the other hand, the data integration tools used for traditional data warehouse systems does not going to work for your emerging systems like Hadoop or cloud data warehouse. The companies end up building their own homegrown solutions, or they buying point solutions, which is very specifically to the technology or particular use case. That leads complexity of managing more technologies and more tools, and that required new talent to acquire new talent. Overall, it is going to be the complex situation. So let's see how Diyotta is going to help to overcome these kind of challenges. Diyotta's unified and modular approach delivers a single enterprise data integration solution to manage and unify these different, the data platforms. In a way, Diyotta is purpose-built for multi-platform data architectures. For instance, if a company has a traditional EDW and the data lake on Hadoop, and they're planning to acquire cloud data warehouse for the new data it is coming. And in this scenario, you need a tool which actually manage all these different types of data repositories, as well as bringing the data from all the different sources. So in this scenario, I would I would say that the Diyotta is the tool architected to manage this kind of scenarios or the use cases. The Diyotta's controller and agent architecture is very unique and flexible to deploy on-prem or cloud hybrid environments. Basically, the agent is deployed at near source or at the source to extract, load, and transform the data. So just to give you some understanding how it can be done through the Diyotta. So the slide shows here, it's a single Diyotta job flow where you can include artifacts or the jobs to manage different types of data platforms here. If you look at here, you have a Hadoop jobs, and there is then we can have a there is a dependencies going into the Redshift job here, or once the data is processed on Hadoop, and then you can take further into the Teradata, which is on-prem. And similarly, I'm just showing here as a simple, Google BigQuery and Snowflake scenarios. So it means, it's a one workflow or the job flow where you can see these different types of, the data, either data movement or the data integration processes can be included, and it can be you can create dependencies between those processes, and basically it will give you one solution for managing all these different types of platforms. So let me take a little more deep dive on the 4.0 features here. So we are basically with the 4.0, we are introducing three-fold here. One is complete user experience. We transformed our when you compare with the prior version, we re-engineered our UI, and also we are introducing the data warehouse features and streaming features. Let me a little bit deep dive onto this the UI aspect. So this new UI, which we re-engineered using HTML5 and AngularJS, and also we took an opportunity to introduce more features which improve the user experience and the developer productivity. And also by the way, all our functional modules are the browser based. So in order to get the faster response on the browser, we followed certain techniques to manage the browser cache efficiently, and by compressing the data from the controller to the browser. And also we introduced a new feature where developers while they are building their rules, they can actually look at the data. So the most of the traditional ETL tools are rule driven, but in order to debug, it has to have a separate process, or you have to run the pipeline to look at how the rules are producing the data and all. So but in case with our new approach, while developers are building the rules, they can look at the data. So that is one of the feature which we're bringing up. So the second, the other feature we are bringing here is to support on different cloud data warehouses like a Snowflake, Google BigQuery, and Redshift. So this slide shows the typical deployment of Diyotta in the cloud. So the Diyotta controller is sitting on the cloud, either of the cloud, any of the cloud, AWS, Azure, or Google. And we have an agent sitting here. A1 is an agent sitting is on-prem, and there is another agent is installed on the cloud. So in order to bring the data from on-prem sources to your cloud, the controller send a request to the agent one to extract the data, and then it based on the configuration, it compresses, encrypts the data, and push over the network to the agent two, which is on the cloud, which basically decrypts and send it to the warehouse. Once the data is ingested, loaded into your cloud warehouse, and there is another instructions will send it to the agent two to build any facts and dimensions on the warehouse based on the metadata which you created, or the data pipelines you created using the UI. So basically, it is now in another way, A2 can be acted as a source. So in some scenarios where you want to grab the data from your cloud warehouse to push the data to your on-prem, let's say you have a Teradata or Hadoop sitting in on-prem, you can just push the data from A2 to A1, and the A1 will decrypt the data and push it to your Hadoop, and the instructions can be sent it to A1 for doing any transformations on the on-prem platform. So the agent and controller architecture is very flexible. You can actually, based on the company's architecture or use cases, you can deploy controller either on-prem or in the cloud. You can, based on the use cases, you can just deploy, the agents, and then just we can manage, multiple platforms in a very efficient manner. So the feature which we are introducing here is, we are really excited to introduce this feature. So far we have the batch type of, we manage the batch type of workloads using different types of underlying systems, like, we can run a transformations on using a Spark or Hive, Taze, or any other MPP platforms or the cloud warehouse technologies. But now we are introducing to address the use cases, real-time use cases. We are introducing the Spark streaming. Basically, with this new introduction, we actually say that we can support Lambda architecture here. There are certain scenarios where you want to get the data in real time, and also the same data has to be flow through your batch layer. And some scenarios where you want to have a lookup from the batch data to your real-time streams. And also there is a when the real streams are real-time, the data is streaming, then if there is any alerts and notifications, or if you want to really call the batch flow based on the trigger identified on the stream, you can raise that. So we are introducing all these features, with 4.0. So with that, I'm going to, I just want to recap on Philip. He described about, what are the solutions we need to look for on MDAs for data integration perspective. So minimize the data integration infrastructure. So basically, the Diyotta has controller and the agent very lightweight Java-based software, which can be deployed in a VM or Linux or Windows software. Windows operating system, and which I explained in my previous slides how unified way you can manage these different types of platforms. And at the same time, we wanted to leverage underlying platforms for the processing engine. So the MPP architectures or the modern architectures like Hadoop or the cloud warehouses are actually meant for to do the ELT. So our core principle is wherever it is possible, we wanted to push the instructions to the underlying platforms where you can make use of them. So that is our core principle. And also we are bringing in a lot of enterprise level features, where you can reuse your rules, or you can define a global objects or global designs where you can reuse in multiple projects. Or we are bringing some innovative way of building the parameters and SQL parameters, which will help to reuse a lot of work across the projects and the layers. And also another thing is, since you are having only one tool, and which is completely metadata driven, and you are building the data integration artifacts, using the single tool across these multiple different platforms, you'll get a the maximum visibility across your processes. So, and the other thing is, since agents are very tiny softwares, can sit in on source or extra on near source or close to target. It can be based on your workloads. You can deploy more agents which will participate in our high availability scenarios or the load balancing scenarios, and which will help you to scale up your overall solution. And also, if you're bringing the new platforms to your mix, for example, if you're bringing the cloud data warehouse, to the existing your data fabric, then you can use the Diyotta to expand your data fabric to the new platforms. So basically, the architecture itself is naturally comes with scale up. So that's a good thing. So with that, I'm going to jump onto the demo where I'm going to give some brief understanding about our UI changes, and then I'll showcase cloud warehouse support as well as the data stream use case. Let me share my screen here. Okay, so this is the studio interface. We have different modules here: studio, monitor, scheduler, and lineage. Data for the data lineage, and also we have an admin module. So this is a new UI which is developed in HTML5 and AngularJS. And this is a dashboard for the project. You can create any number of projects, and also projects can be global project where it can be shared. Whatever the objects which is included in the global project can be shared across the other projects. So that is a reusable aspect. And we have a data points which are basically the connections which keeps the details about your sources and targets or the native processing platforms. We have a data objects which are basically the definition of your table or semi-structured like JSON, XML, or Avro Parquet definitions. And we have a data flows and the job flows. I'll go over in detail those. And just to give you some understanding on the UI, the interactive design approach we are taking here, let me show you along with the cloud warehouse support here. So let me take an example of Snowflake. The Snowflake is cloud warehouse cloud warehouse which is hosted on the AWS. So we do support any here. If you look at here, we have a connection for the data point for Snowflake. We have a Google BigQuery and the Redshift and the Spark, and all these are the different data types. So if you look at the connection of the data point of the Snowflake, where you can just need to give the information about your connection here, which automatically brings the what type of data. What is the stage of the status and the size of the cluster. So, and with that, I'm going to jump onto the, one second, let me reload it. It was, okay, so let me take you to the one data flow example here. Data flow is basically the batch flow in Diyotta. And here, if I take an example of, F order here. So basically, which is the data is, in the cloud, which is in the Snowflake. And we have a different transformations here. We are joining these two Snowflake tables and rolling up, and then we are joining further and pushing the data into the Snowflake table. And if I want to showcase the interactive design approach here, which basically brings you the data on the roll-up itself. So here, if you see this, this is the data which is, so Likewise, you can view the data any transformation level. You can view the data at the joiner, or you can view the data on the rollup. And if you want to, let's say, for example, if the developer want to create an additional attribute here with a new rule here, let's say if they want to create another total amount here, we just want to round up the total sales amount here. You can just create that and look at the data. So basically it recomputes that the values, and it will show the data on here. So basically likewise you can just create your rules and keep on looking. You don't need to really switch to other at runtime to view the data, validative data. So and the other feature we are trying to bring here. If I go to the data object here, this is the table, like a snowflake table, and you can actually view the data directly on the table. Which brings the data from AWS, and in this case, it is coming from the AWS. And also, we can just switch to the SQL editor. You don't need to really switch, other tools to look at the data. So this experience is very similar for any type of data flows. It could be it is the same for your Hadoop or the Spark, or if you're doing for Redshift or Google BigQuery. So the experience is not going to change. So just to showcase the same thing, you can just build the same workflows here. This is the Teradata, and it's the same thing you can build using Hadoop or the Spark define data flows. So there is a facility where you can actually convert your Hadoop data flows into the Spark flows, which way sometimes if you want to start with using Hive as a your processing framework. Then later, if you want to convert that into the Spark, you don't need to really redo the designs. You can just use our accelerators to convert them quickly. So with that, I'm going to jump onto the use case, the streaming use case quickly. The streaming perspective, we introduced a new component called data stream here. Here we have it's a very similar, the user experience perspective, it is very similar, drag and drop, the components here. In this case, you have the data is coming from your Kafka, and then we are, the event is actually, we are passing the event using with all the functions which you use the Spark. So basically, here you are using the regular expression to parse it, and you can use pretty much there are so many functions available here to use it. These are the Spark functions, and then once the event is passed, we are diverting the data to the based on the conditions. We are just diverting to the different things here, HDFS, or there are some going to your Kafka topic itself. And also one of the feature which we are introducing here, where you can actually use a lookup based on the static data. So in this case, we are actually going to the Hive table, and in the real time, the stream is looking into the Hive table, and based on that, it derives the rules, and then finally it sends to the sink. So there is other features available to raise the triggers. Based on the triggers, you can call the batch flow and all. So these are the pretty much you can while this running, you can monitor your Spark, the jobs and statistics, and how those things, and also you can bring the how many batches are running, what is the number of records are for each batch is loading, and all those statistics you can just run through the log file. So with that, we have a 10 minutes more, so I'll just keep for question and answers. John, I think I'm done with this, and over to you.
Awesome. So I want to open it up now for Q&A. So feel free to go ahead and ask any questions that you might have at this time. and I'm gonna go ahead and begin with with some of the questions that have already come in. So I'm going to start with you, Ravi. You mentioned being able to crawl and capture metadata from source systems. How exactly does that work, and what metadata do you capture?
Yeah, so in Diyotta, we have a facility where basically we registered the metadata from source and target systems in Diyotta Metadata Repository. So in order to bring the metadata, we have a facility where you can go and you can allow Diyotta to go into the source systems and look at all the metadata, like the table definitions and the constraints, and in case of a Hive, you can look at the partitions of the table, and if what type of format the Hive is building on, is ORC format or Parquet. All the details are going to bring it to the repository for registration. Once the data is registered, then you can start using those definitions in the data flows.
Great, thanks, Ravi. Philip, I also have a question for you. What should be the priorities for companies or IT executives moving from silos to a multi-platform data architecture? What are the priorities you would recommend?
Yeah, I see that question as it came in, and they're asking for priorities for IT executives, but I would also say business executives fall into the same category, and that's because there's certain things that can only come from an executive, things like business backing and business sponsorship, and also both IT and business executives can communicate and decide whether or not there's truly a return on the investment of this large data environment. Don't forget, these MDAs I was describing, that's a lot of software licensing fees, that's a lot of capital expense on hardware, that's a lot of hiring and training to get people the skills for that many different types of platforms. So we need the executives to be sure that there's a good business case behind that. And then also, we need them to provide funding, right? We need them to reach into their budgets and come up with the money for that. But the main thing is this really going to have something for the business? And in general, there are certain business drivers behind multi-platform data architectures. One is that quite often the business, these are really, this would be the chief executive officer and people quite often powerful like chief marketing officers who are going to tell you, look, for us to be competitive, we need to do more analytics. So it's the need for greater analytics that are causing a lot of companies to collect data in greater volumes, but also in greater variety than ever before. And so a lot of those kind of determinations have to be made by the executives. But that's kind of upfront. But over time, it's those same guys who have to provide the sponsorship and the funding.
Thank you, Philip. Ravi, I've got another question from you. My guess is that folks on the call are implementing the Internet of Things in some way. So the question is this: can your agents sit on edge devices and push data into data flows? Ravi, you may be on mute. We can't hear you.
Yeah, John, sorry about that. Yeah, yes, the agents can sit on the edge. Basically, the agents are very lightweight. It can sit in any Linux or Windows operating system and extract the data and push the data to other agents or directly to the platform itself.
Thank you. And Philip, another one for you. As companies move towards a successful MDA strategy, what are some common mistakes to avoid?
Oh yeah, at TDWI we actually have a series of reports called 10 Mistakes to Avoid. So we're really good at helping people understand where the potholes are so that you can steer around them. So with the common mistakes to avoid with a MDA strategy is, first of all, realize that it's more than a portfolio. It's more than just a list of data platform types and integration tools and analytic tools. That you have to have a true architecture. A real architecture is based on dependencies and relationships among the different pieces of the architecture. And so I'm really talking from a technology and architectural viewpoint. So one thing to avoid is just having a bunch of disconnected stuff in there. And John, I know earlier you and I were talking about data silos and how they're still a problem. Well, the multi-platform data architecture can deteriorate into a bunch of silos if people ignore the architectural pieces. And so, you know, that old expression, no man's an island, well, wouldn't it be nice if we could think about databases that way, that no database should be an isolated silo. And so if you're working on architecture, getting beyond mere portfolio and inventory, then that's going to help you. Another quick thing, you know, when I mentioned the executives earlier, you know, those guys need to be involved in data governance, because if you think about the complexity, the many different places where data is physically related, that's a tough environment to govern and do similar things like data stewardship. And a lot of people want to do this modern thing called data curation. So you need executives to A, tell us we're all going to do this, this is part of the job, and that B, here are the business guidelines for governance. And quite often those will be based on things like compliance issues, because that's the kind of governance infraction that can hurt the company the most. And then also C, here's some sort of team structure like a data governance board or committee or something like that. And we're going to populate this with the right people so we can communicate and govern the multi-platform data thing. And then finally, just keep in mind that one of the assumptions behind the successful multi-platform data architecture is that we're going to treat data like an enterprise asset. And if you don't, otherwise, people who own different platforms and that data, they're just going to argue over turf wars and ownership problems. So quite often, how do you solve that? Well, quite often it's someone at the highest level of management who says, okay, you know, you guys are stewards of this data, but that doesn't mean you own it. You have to share it, and you have to be a good steward to take care of the data, make sure it's integrated into an architecture and all the stuff we just talked about, but also that it's shareable with other people. So you need someone, you know, a powerful executive to redefine data ownership. Otherwise, the MDA, the multi-platform data architecture will never be fully stitched together.
Fantastic. Thanks, Philip. Ravi, I have another question for you. I've seen some of the new streaming data integration tools. What are you doing different than them?
Yeah, sure, John. So yeah, that is right. I mean, there are a lot of tools, complex event processing tools, which are addressing only the streaming use cases, and some level of batch type of workloads on the modern architectures. But where Diyotta actually have core architecture is built on supporting these multi-platform architectures. So we address both batch and stream use cases together, and also there are certain features where you can combine these two different flows together to achieve the different use cases.
Awesome, Philip. I've got one for you. This is probably something you're very familiar with. How can we achieve immunity against the rapid evolution in the data landscape? And the comment was added, as we start implementing in one pattern, we see another pattern popping up the next day.
Yeah, that is a challenge, isn't it? But also, don't forget, at TDWR, our biggest business is training people with the new stuff, whether it's new technologies, new platform types for data, new design patterns, which I think is what you're alluding to. And the most recent design pattern, of course, is the data lake, right? And we now find, it's oddly enough, we now find data lakes pretty well ensconced in a lot of data warehouse programs, because the lake with Hadoop, like that reference architecture I gave a minute ago, it's really useful in some areas, especially data landing and staging, or a more modern approach to landing and staging, as well as collecting detailed source data together for analytics. So the thing is, we do want to take a serious look at new design patterns, new platforms as they come out. And of course, a lot of the innovation today is coming from open source. So there's new open source tools and platforms coming along. And let us not forget cloud. So far I haven't had a chance to say cloud much here. That's actually one of the growth areas we're seeing most at TDWI. We're seeing all sorts of data bases and data sets going to cloud storage. We're also seeing just just about every other trend there in our membership, everything from software as a service applications right on up there to analytics on the cloud. So, you know, when I show what's going on to people, and I show them what's going on with the multi-platform data architectures, you know, some people get nervous because they look at it and they go, wow, that's really complex. Complexity can be its own challenge because it's hard to just get your head wrapped around the inventory of these platforms, much less their true architecture, which is based on relationships among them. And yet, I see people succeeding with this all the time. You know, data warehouse professionals in particular have been dealing with highly complex, bimodal, if I can borrow that term from the Gartner guys, you know, systems of different vintages working together side by side, and today hybrid environments with different definitions of hybrid. We see people succeeding with that. So despite the fact that the complexity keeps going up, despite the fact that there seems like there's a new design pattern coming along, we do see users dealing with it. And to a lot of people, they take a different attitude. They look at it and go, wow, there's something new. Let's look at that, because that might be the thing that's going to help us with a certain analytic application or a certain way we wanted to leverage operational data, something like that. So I do see people pretty eager to glom onto the new thing and try to find a place for it. And if there's no fit, you know, no problem. At least they educated themselves about it.
That's such a great question, Ravi. I'm going to pass this over to you regarding this immunity question. How does Diyotta help manage the changing technology landscape on behalf of their customers?
Yeah, that's really good and challenging to cope up with the changes that are happening in the market today, especially in the open source world. So the way the Hadoop perspective, there is almost every month there is a new version is coming, and so the approach what we take is, you know, the core architecture, the way we built on is, you know, not. It's a metadata, completely metadata driven, and these are the underlying platforms are extensions. Meaning, you know, there is every processing platform is an extension for us. You know, today there will be a version which is releasing from Hortonworks, 2.6 or 2.6.4. Then it's a matter of, you know, we just, you know, we compile that version and, you know, give that as an extension to our customers. So it's not really touching the core, but it is basically underlying, you know, the whatever the modified, you know, extensions go into our repository for the as a patches manner. I just gave an example in a Hadoop, so it's a very similar for all other platforms.
Fantastic. Well, thank you, Ravi, and thank you, Philip. Thank you, everyone, for joining today. There's just a couple of places where you can get some additional resources. The 4.0 datasheet has more information about that product. If you'd like to request a trial version of the software, you're able to do that online. If you happen to be more technical and want to drill down into documentation, that is there. There's also some of the latest blogs on Diyotta 4.0. Thank you again, everyone, for joining, and we look forward to speaking with you at the next Diyotta webinar. Bye now.